Hello friends. So in this lecture we will discuss in detail about the damping force. The damping force is required to remove or damp out the oscillations so that there will be no any unnecessary movement of the pointer. The pointer will be at a steady state position, not at a zero. It will be at a steady state position where it has to be, means on the scale, indicating a accurate measurement. So to provide the damping, there are three different systems: air friction, fluid friction, and eddy current. Let us see one by one. Air friction damping. The diagram indicates that there is one cylinder, there is a piston. That piston is connected to the spindle. Spindle is nothing but that is a spring or a coil wound with one axis, and that to the spindle a pointer is connected and pointer is raised over the scale. So the piston is mechanically connected to the spindle through the connecting rod. The pointer is fixed to the spindle, moves over the calibrated dial or the scale. When the pointer oscillates in clockwise direction, the piston goes in and gets compressed. The air pushes the piston upward and the pointer tends to move in the anticlockwise direction. So for every reaction there is a equal and opposite reaction by this air friction. That air friction is on the piston which is moving in the cylinder. If the pointer oscillates in the anticlockwise direction, the piston moves away and the pressure of the air inside the cylinder gets reduced. The external pressure is more than that of the internal pressure. Therefore, the piston moves downwards. The pointer tends to move in a clockwise direction. So, this piston makes the pointer to retain at a stable position by damping out the oscillations. A similar function is in the case of the fluid friction. That friction is provided by the fluid, that could be the oil. Let us see the next one, eddy current damping. See, in the eddy current damping, an aluminum disc is pivoted in between the two supporting structures, and that aluminum disc is kept in between the permanent magnet. That permanent magnet is nothing but the damping magnet. Let us see the description. An aluminum circular disc is fixed to the spindle. This disc is made to move in the magnetic field produced by the permanent magnet. When the disc oscillates, it cuts the magnetic flux produced by the damping magnet. An EMF is induced in the circular disc by the Faraday's law. Eddy currents are established in the disc since it has several closed paths. So by Lenz's law, the current carrying disc produced a force in a direction opposite to the oscillating force. The damping force can be varied by varying the projection of the magnet over the circular disc. See, let us in the detail. Here we have used the aluminum disc. The disc is supported by the certain mechanical structure. The disc is connected mechanically to the spindle. That spindle carries the pointer over the calibrated dial or the scale. That aluminum disc basically decides the movement of the spindle, and obviously in respect that of the pointer over the calibrated scale. So the oscillations of the pointer are getting controlled by the movement of this aluminum disc, which is placed in the permanent magnet. That aluminum disc produces the eddy current. Why eddy current? When there is a closed path and when there is a potential difference, current start producing or flowing through that closed path. Here the closed path is aluminum disc, which is placed in the permanent magnet, produces its own EMF as it is moving in between the magnet. So as we told you, Faraday's law of electromagnetic induction effect, E is equal to d phi by dt. So EMF is induced as disc is cutting the stationary or permanent magnetic flux. And as there is a closed path, that EMF gets converted to the current. So that current is nothing but the eddy current. And here, as we knew that E is equal to minus d phi by dt, where minus is nothing but the sign indicated by the Lane's law. So Lane's law opposes the cause of production of the EMF, cause of production of the current. And what is the cause? That cause is movement of disc. So disc is got opposed for the movement, free movement. And as the disc is connected mechanically to the spindle, spindle avoids the unnecessary movement. There is nothing but the dampings are provided on this system with the help of the eddy current. So oscillations are removed. So pointer comes to the steady state position. So this is nothing but the eddy current damping. So damping is nothing but to remove the oscillations so that pointer will come to the steady state position, indicating the accurate result. Thank you.